Hi, I'm Stephen Conrad. I'm Associate Professor in Systems Engineering, and my research focuses on human systems coupling, whereas I get to explore elements like how we make decisions together with our physical systems, and I combine a variety of different tools for that: simulation modeling, artificial intelligence, and physics-based models. And ultimately what I hope to explore and do really explore are the variety of interlinkages between our water systems, our energy systems, and our really people systems to ultimately create and understand urban environments so they're a bit more sustainable, resilient, and climate adaptable.
Hi, my name's Jim Adams, and I'm an assistant professor here at Colorado State University. My area of research is really leverages off my work at Lockheed Martin in space systems. We're just getting started on our space focus growth area here at Colorado State, and so we're starting to leverage some of our students who are interested in exploring new solutions in space.
Why don't you start, Jim?
Well, thanks, Steve. In space systems, we really are looking to help with the development of exploration systems, information systems, and communication systems using space. Space is a great place to grow some of the capabilities that we need to solve some of the bigger problems on Earth, as well as leverage space as a way to solve some of these problems. So here at Colorado State, we're looking for some of those research areas that we can then grow through our students and through our research to help solve some of these bigger problems.
Yeah. You know, one of the things I find really great about our sort of expansion in space is that most of the work I do is on terrestrial systems. And so with our terrestrial systems, we've often looked at how we manage water separately from managing energy, separately from humans, and how they make decisions. But when we look at space, it's really like ultimate closed system where you have to understand how these systems are interlinked, how they function together, how secondary effects occur if you mismanage one particular element. And so a lot of what my research I see focusing on is bringing these concepts down to our urban environment so they can be more regenerative. So instead of just taking materials, moving through our cities, and then trying to send them out as waste, actually looking at waste, recovering some of the resources, is relinking them back together, and understanding how we can transform our systems to be almost like a space model where our communities and cities are enclosed and encapsulated and generate new services and new opportunities for other communities.
Right, and some of our students are already looking at the lunar systems as part of the Artemis program. The United States is already looking to put people out to the surface of the moon and start developing systems or habitats there. And they need to be thinking all the way up to the beginning of the stream. How are we going to be able to reuse this resource? Because they've got nowhere to throw it away and they don't have much to start with.
Yeah, like a big expansion, or we look at data. Data is becoming ubiquitous now. So how do we manage this data? And so what I'm going to be looking at is really expansion of human AI and machine learning techniques and artificial intelligence to bring that data down to decision makers so that they can visualize the information, they can understand it, make decisions that are applicable, try to solve some of these problems. I mean, I get tired with this phrase called wicked problems that we address here on the Earth all the time. It's like a wicked problem because we can't understand it. And I think systems engineering is a great place to help us put a framework around these wicked problems so we can start to address them.
As with many systems, big systems problems, space problems are complex. A lot of times we're solving the problems we discover as we operate the systems in space. Going to the moon, going past the moon to Mars, deep space, we keep finding and solving problems while we're executing the missions. So yes, the contributions we get from space systems, systems engineering in space systems, have a lot to do with figuring out how to deal with emergent behaviors, undiscovered challenges in a system that's already operating. And that can then be brought back to all the other systems engineering problems that we learn and challenge ourselves with.
Yeah, I think one of the first concepts I teach my students is to look at behavior as behavior over time versus just an impact or an event, right? And so we're trying to solve, engineers, we like to solve events or problems. There's a fire. And you say, but really, what are we looking for? Is that fire at a particular event, or how does it change behave over time, and really understand and explore the evolution of the system behavior versus that? That's actually really great. So I'm trying to, a lot of what I'm doing is trying to bring in some concepts from ecology, where we explore how the systems are moving through their adaptations and evolution and enable us to be able to quickly adapt to them. And that requires us to know a lot more about what's happening in our systems as an instance, instead of living in the dark.
Yeah, and even though I'm a space guy, I love the woods. I love being out there. I spent a lot of time camping, hunting, and I see those things in motion. And I think to myself, as a systems engineer in the woods, how did they evolve to do that? Why are these systems so resilient? And I love coming back to INCOSE conferences when the system sciences people get together and we talk about how can we study the systems that are in nature and figure out how we can bring that into our engineering of our systems and our understanding of the systems we engineer.
Yeah, there's a concept in climate science called non-stationarity, right? And so as systems engineering, I think that kind of bringing that principle of non-stationarity to the way we look at engineering problems, I think it's going to be a real growth opportunity and real growth in the next 10 years. So Jim, what do you think we need to focus on here at CSU over the next decade or so for education?
Well, I come from an interesting position because I am working in industry at this time. So for me, I want to see more involvement with industry, between industry and the university, more opportunities to take problems that industry has and help to move them forward, take opportunities that the university brings with resources, students, research we're already doing, and bring those to the industry and to the companies and help them step forward more quickly.
Yeah, I mean, this is an excellent education opportunity for trying to help students who are studying systems engineering to link with those problems that are in industry. So I think I used to call that sort of industry-led problems or community-led research, where you're working and defining the problems that we're trying to explore through science with those that are going to apply the outcome. And then so it's kind of turning the problem upside down, right? So in science, we often will say, okay, let's do the core principles, but let's actually always keep that vision in mind. Other areas that I can see us growing on are those like human factors and human decisions and human elements, and things that we really see how they couple together. Obviously, it's an area I explore quite a bit, but that's a growth. Better means for managing data, better means for simulation, better opportunities for framing the problems. Yeah, it's definitely a needed area.
And the tough problems are always going to require people to help solve them. Yeah, there's a lot of solutions out there that are highly technical, they're highly integrated, and we get great things done. Cell phones, computers, some of the data communication networks we have, they're automated, they're working. But when we take on the big challenges of the world and beyond, we need people in there. And so we need to know how people become part of that system that we use to solve those problems.
Exactly. I think one of the big sort of concepts around systems is the notion that it's interdisciplinary. And so when those that are sort of moving into system engineering from other disciplines have been focused on a single core discipline, like mechanical engineering, learning about thermodynamics. And so as we move into systems engineering, we're finding lots of linkages, right? And so one of the things I always say to my students, that you didn't know you were a systems engineer until you found us, right? And you realize that, I was a systems engineer the whole time. And we can apply the same concepts with communities and professional associations, right? So, INCOSE is great, but what are the linkages with IEEE and other opportunities, right? So I always encourage everyone to do multiple linkages and to see and learn the language of other disciplines and learn the opportunities that connect.
Yeah, that's a good point. Systems engineers get themselves into a lot of things, and then they see those linkages. They tend to be somewhat innovative that way. They see the pieces and they connect those. And yeah, same thing with professional societies, organizations. Get involved in a couple and be some of the connectors between them. And my wife often calls me a glorified communicator in the office, because as a systems engineer, I'm trying to help the other engineers get their point across. Not only the engineers, managers, customers, stakeholders, suppliers. Everybody uses a different language, and systems engineers have a way of seeing the system behind the language and then trying to get people to get the image.